Yeah, so the last time we talked a little bit about just fundamental stuff about Clojure, what it is, the programming language itself, and sort of went through a lot of different, like the basic data structure, literals, stuff like that. We showed how to define functions. We showed how to do let expressions and have local variables, that sort of thing. And we showed that you can have modules and import stuff between modules. Let's see, what else did we do? We did a bunch of, we talked a little bit about the fact that you can do development and sort of interact with the program as it's running, which is a very important aspect, and we will keep doing that in this session as well. I think in this session we will be talking primarily about doing interop with Java, because like we talked about in the previous session, Clojure is hosted on the JVM and is very much built with the on top of Java itself. So you have access to the entire JDK, and you are sort of expected to make use of that for a bunch of stuff. So just sort of a quick recap about the syntax, that you always sort of like everything is written as these nested lists like this, and a function call is basically just the first part of the list is a function, and then you supply a bunch of arguments. And so this is a print line function call with a string argument, the result of another function as the second argument. That's just adding two numbers, and the result of a third function is the third argument that reads a file from disk. Let's get into it, I think. Thank you everyone for coming. We will be looking at some interop with Java in this session. So in Java you have access to the entire JDK. So if I wanted to create an instance of a class, I would just call that constructor in the same way that I would call a function. So this will create a string, and I guess I'll put some, this is effectively running the copy constructor of that string. And if I evaluate that, I get a string literal back here. And you can note the constructor is actually called by just putting the name of the class and a dot. So if there's multiple constructors with multiple arguments, you can just keep typing arguments to this here. So this is actually equivalent to new string ASDF. So that in Java. Now, if you wanted to call a method, it's quite similar. I'm just going to create another string here. So we do a string, and we do, let's just grab this one. Let's see, there. And if I wanted to call a method on that string, it's very similar. I would, but what you would expect in Java is that you would put something like a string dot something, like char at maybe. I guess that's going to be a number, so chart1, I guess. So that's the syntax in Java, and in Clojure that becomes, so you always start with the method name, so that becomes dot char at string, so that's the this argument, and then the rest of the arguments. So it literally transforms into something that's just the same as a function call in Clojure, but with prepended with a dot. So this should evaluate to s, I guess, the second character in the string, because it's just one index like that. So that's a method call on an instance. If you want to do a method call on like a static method call, the syntax on that looks similar to if you wanted to call a function that's inside a module in Clojure. So if we do like system/get property. And I guess there's a Java version or something. And as you can see, that evaluates to that value. So it's the same thing as calling a function inside a module, like that. Now you can actually call methods using a different syntax as well. This one up here with the dot prepended and included, like the method name like that, can also be typed like this, like dot string char at 1. Oh, there we go. And actually I probably need that bit as well, don't I? And to indent that. So there we go. So there's that syntax as well. This is not as common, but it might be useful to know that it's there, because you can sometimes want to maybe create macros or something like that that would be simpler to do in this fashion. And there's also a converse thing that you can do that allows you to call multiple methods on an object in a chain. So if I had a string builder, the string builder class is nice for this purpose because it actually returns itself on every call. Like if you append to a string builder, it returns the string builder itself. But here I can create a string builder and then I can chain calls to it. So you can call append. Running Java space, and then I append system get property Java version, and there we go. It's actually harder to type than I envisioned it to be. And I guess certify, so that the first call returns, it creates a new string builder. The append function returns another string builder and sort of pipes in the original string builder here as the first argument here. So it replaces it in place that. It calls this method on it, and the return value from that is put here implicitly in front of the second argument. And then finally I can do toString on this. And it will call the toString method on the return string builder, and it doesn't work. Because there's no... Oh, sorry, there shouldn't be a dot there. It should be like that. So you can see it actually builds up the string. So this way you can actually sort of chain a bunch of stuff, and there's a bunch of Java APIs where you sort of get a property, and then you get the factory, and then you get the builder, and then you get the, that sort of thing. So it's just to sort of decrease the complexity of that a little bit. Another common thing is that you might want to sort of configure something a little bit. A very common pattern in Java is that you create an instance of a class and then you run a bunch of methods on it to configure it. And in the case of the string builder, that actually returns the string builder every time, so you can use the dot notation for that. But for a lot of that convention kind of changed, that got sort of out of fashion later in Java, and the convention was that whenever you have something that mutates something and changes something, like a set function would always return void, so you wouldn't get the thing back unless it was like a specific builder type class. So if we wanted to deal with something like that, I can use a similar way. So I'm just gonna set up just really gonna try this out there and do a frame, like create a window here, and I sort of, so this is going to be Java swing frame, or I guess AWT maybe. That's not how you do that. Just complete that, import that one, and you can see that I got help here and auto imported the class I needed from that. Now whenever you type a Java class like this, you can actually type the full name like this instead. Just sort of, instead of importing this, I can type the full namespace. I'm just going to move down a little bit because I know that it's kind of hard to see that. But here, if I can also sort of like import multiple classes from a particular namespace, and they will be available here. So I can keep listing stuff here. I can maybe add, I don't know. I don't know anything that's in this namespace, but if there were additional things, I can list them like this here and import several things and have them available. So what I'm doing here is I'm creating a new instance of a frame, and I'm using the do-to macro, which allows me to call multiple methods on this in one go. And I guess I will have a nil layout because that comes with some sort of layout from the start and I don't want it. And I also want to set the size maybe. Let's do 400, 300 and do, so we do background. Yeah, there we go, sorry. So do a background and we do orange. And I'm probably gonna have to import that as well. That's fine. And the last thing I need to do, I need to show the window as well. True, maybe? Right, so what this does, it actually performs, it creates a frame and then runs these methods on the frame and just discards the return value of each call in turn. And then when it's done running in those methods, it returns the original frame. So it sort of mutates the frame and then returns it in a configured fashion. So I can do that in one go like that. And this is especially useful if you're creating UIs because you can, a lot of the time you will sort of add a child to another thing and you will add a child to that. And you can just sort of create this nested thing right from the start and just configure it in one go, which is very helpful. So we have that frame there. I am going to, I mean, if I run this, I will probably open a window and that's going to be annoying. Oh, it's not going to be. Oh, so now it's complaining because it doesn't, I haven't actually redefined the namespace. You remember that I imported some stuff here. And I'm getting a compiler error because I haven't re-evaluated the new namespace definition. So if I re-evaluate that and then re-evaluate this, I should get an orange window. And the really sort of annoying thing about these kind of java.avt windows is that they don't even respond to the close events. So I can't actually get rid of it. What I need to do now to get rid of that is do something like from here. Luckily, I can interact with my running application. There's a static method on window, I think. Slash, yeah, so import that. And I think it's called get owner less windows or get windows. Yeah, the owner ones, less ones. I want all those windows and give me the first one of those. And I'm just going to call dispose on that to hopefully get rid of this window. Let's find out. It's there. And it's gone. Nice. So it's no longer there. So you can do that. One very nice thing is that Clojure functions themselves compile to classes in Java. And they implement a bunch of interfaces, so they can interact with Java in a nice way. And one of the interfaces that they do implement is they implement runnable, which means that I can very simply create a thread that takes a function as it's runnable and just run a function in a background thread. So I'm going to do that here. I'm going to call start, because that's a start method on a thread. I'm going to create a thread. And I'm going to give it a function, just a local function like this. And just to demonstrate, I'm going to do a call to sleep. And this is milliseconds, so let's sleep for 1 second maybe. And I am going to post, after it's waited for 1 second, I'm going to close the window. And so it's going to show the window, wait for 1 second on a background thread, and then close the window. And I can't actually close the window from the background thread because I'm not allowed to interact with the UI from the background thread. So I'm going to have to post a call from the background thread to the main thread that closes the window. And the way you do that is through the event queue. So there's a function here called invoke later. Event queue, that's not good. There we go. Import it, same thing. Invoke later takes also takes a runnable. And because function is runnable, I can just give it another function, and in that one I can call dispose on the frame. So let's just recap here a little bit. I'm creating a frame, configuring it, And remember, inside the let statement, this binding is available to everything inside the let statement. And if I create a function inside a let statement, that also has access to all the stuff that's inside the scope that the function was created in. So this actually returns a reference to the frame that was created in the outer scope, and I'm posting this on a background thread, and hopefully this should... yeah, I need to reevaluate the namespace definition again, but here we go. Hopefully it should open a window. It's not. So not sure why not. Maybe we can do like stop and try again. See if it works. It's possible I did this wrong, but I'm going to just restart and reevaluate. There's my window, and it disappeared after 1 second. It's possible that something went a bit weird with yeah, I think I know what's going on. Probably some thread in AVT that is dealing with Windows maybe shut down because the last window was closed. There's often a hook like that will terminate some sort of part of the UI. But that actually disposed of the window, and it seems to work now. So that's how you call methods and use runnables and stuff like that. Now, if you're dealing with Java calls, they can of course throw exceptions. And the way you deal with that is that you have a try construct that can be used. Let's see, let's return something. I need to call a function that can throw an exception. What I can do is I can do try, and this looks a bit weird when you're not used to it, but effectively here is the result that will happen if the exception is thrown, right? So there's an unknown error in this place, and here's the bit I want to call. So if I wanted to call a perform IO function here, maybe just do some disk access sort of thing, I would call that function, and after that function completes, I would return success, right? Now, if it throws any exception, I will instead return unknown error. And this evaluates this entire thing, then evaluates to either success or unknown error. Now, if I wanted to have additional catch additional types of exception, I would just add them here. So I can maybe add a specific IO exception catch here. And I guess I'll have to import that. And I might actually I might return an IO error there, just as a status code for that. Yeah, there we go. So here we go. We call the perform IO function and return success. So this can do a bunch of stuff in here, of course, and then the final expression is what's being returned as the result in case nothing went wrong inside the try. If it throws an I exception, it returns an IO error. If it throws an unknown other kind of exception, returns an unknown error like that. So I guess you also might want to do a finally, and you can use that down here as well. So you do finally, and I guess we'll do a cleanup. Now, if we just sort of mock these functions here, we can do a clean up function, and that's going to be just me printing clean up. And let's do another function where we actually sort of say perform IO. And in this one, I'm going to just throw an IO exception. And down here, we're going to put the result so we can actually evaluate it, or return it rather. So let's try this. And it's going to tell me that I need to redefine the namespace. Fine. There we go. And as you can see, the result of running that function is an IO error because I'm throwing an IO exception from the perform IO function. If I don't do that, I just, I don't know, I return nil. I get the success. And if I throw a different kind of exception, I get an unknown error. And you can see in each case, the cleanup function is run, even if it was successful. So that's how you handle exceptions.